Well, hello everybody, welcome back to Complete Chemistry. Today we have come to the exercise of haloalkane and haloarine to the page number 189. So let's start the video without wasting any time. So the first question is, name the following halides according to the IUPAC system and classify them as alkyl, allyl, benzyl, 1 degree, 2 degree, 3 degree, vinyl or aryl halide. So whatever questions they have given 12 questions. So we are going to do 4, 4, 4, 3 times. And also we have to classify them as alkyl, allyl, benzyl, vinyl or aryl halide. So before starting these questions, we should know what is the meaning of alkyl, allyl, benzyl, vinyl and aryl. However, we have done this in classification part, so we'll just have a quick revision over here. Then we'll go towards the main question. So let's start. First of all, what is the meaning of alkyl? So if any questions have presented in this form, R and X, that means CH3 alkyl group, C2H5, if anything is attached directly with haloalkane, we call them as alkyl. For example, CH3CL, this is a alkyl halide, or we can call it as methyl chloride. Next, what is allyl? If a halogen is present to a carbon and that carbon is attached to another carbon having a double bond in it. For example, here this carbon is how much? sp3. Also remember, this classification is based on hybridization. So here the hybridization of the carbon which is attached to the halogen should be sp3. Here if you also see, this carbon is sp3, but the carbon which is attached to the carbon which is attached to a halogen is sp2. How do we know that carbon is sp3 or sp2? We have already done this in the lecture videos. If the carbon is having all single bonds, we call it as sp3. If it is having a double bond, we call it as sp2. And if we call it having a triple bond, we call it as sp carbon. Okay, so this is known as allyl group. Okay, next is benzyl. Benzyl should have a benzene ring, but it should not attach directly with the halogen. If it is directly attached with the halogen, this carbon becomes sp2. This will become your aryl halide, not benzyl halide. Students get confused with benzyl and aryl. If halogen is directly attached to the benzene ring, we call it as aryl halide. However, if the benzene is attached to a halogen using the help of a carbon, then we call this as benzyl, because the carbon which is attached to the halogen should be sp3. If you see here, these first 2-3 categories comes under sp3 category, and this vinyl and aryl comes under sp2. What do I mean by this sp3 and sp2? The carbon which is attached to halogen should be sp3 and the carbon which is attached to halogen should be sp2. Here if you can see, the first category is sp3, here also sp3, here also sp3. So alkyl, allyl and benzyl. So whatever remaining is now is vinyl. What you do is vinyl and allyl is almost same, but there is only one difference. Halogen attached to the carbon should directly attach to a double bond, because we have to make this as sp2. So this is known as vinyl carbon. So I hope you are getting the point, like what is the meaning of alkyl, allyl, aryl, benzyl and vinyl. Carbon attached directly to the halogen, sp3, we call it as alkyl. It is attached to a carbon with a double bond, it is known as allyl. The carbon attached to the halogen should be sp3. That means it should have all single bonds. Next, if it is directly attached to a carbon and then it is attached to a benzene ring, we call it as benzyl. Directly attached to benzene, aryl, and directly attached to a double bond, vinyl. So I hope you understood this part. Now the question is, what is this primary, secondary and tertiary? The carbon which is attached to halogen, it attached to how many other carbons? Give you the degree of the carbon. For example, here this carbon is attached to none of the other carbons, so it is 0 degree. Here this is attached to this carbon, you have to think about, because it is attached to the halogen. It is attached to how many other carbons? Only one, so this is 1 degree. This carbon is attached to one here, so 2 degree. We are talking about this carbon, okay? This carbon is attached to 1, 2, again 2 degree, and this carbon is attached to only 1, so it is 1 degree. So this is known as 1 degree, 2 degree, 3 degree classification. So I hope you understood these points. Okay. So once you got this point, it will be very easy for us to do this one. So let's jump into this one and see how we can give the classification and the name of following compounds. So before naming it, what you have to do is first open the structure. Until you open the structure, the problem looks little bit complicated to us. So I'll just write the similar structure. Whatever is present in the bracket, that means it is attached to this front carbon. So CH3 CH CH3. See, this was the CH, these are the two CH which is present in the branch form. Next, again there is CH and it is attached to a chlorine and CH3. Okay, check that all carbon are having the 4 bonds or not. This is, for example, this carbon 3 with hydrogen, 1 here, so 4 over. This carbon 1, 2, 3 and 1 with hydrogen, 4 over. 1, 2, 3 and 1 hydrogen, 4 over. This 3, 1 and 1, 4 over. So once it is done, also if you have a little bit more understanding, you can draw the bond line structure of this and make it your question. Looks more easy. Okay, so let's start numbering and name it. Here is your halogen, so preference will be given here. So your numbering will start from here. 1, 2, 3, 4. You can even number here, that will remain the same. So we have 2 times chloro, and then we have a branching 3-methyl, then we have butane. So butane. So 2 chloro, 3-methyl, butane. Also now you have to give the degree of it. Now you have to find the degree. How you find the degree of which carbon? The carbon which is attached to the halogen. This carbon. You have to find the degree of this carbon. Now if you can see here, this carbon is attached to how many other carbon? 1 carbon this side, 1 carbon this side. So this is 2 degree halide. Okay, so you can write it here 2 degree alkyl halide. So just write it here 2 degree alkyl halide. So this is your complete first question over. I hope you are getting the point. Again, you have to follow this. Then open the structure, count halogen where it is, give the numbering, write the IUPAC name, and find the carbon which is attached to the halogen is attached to how many other carbon. Same thing you have to do here. First open the structure. CH3 CH2 CH CH3. So CH3 CH2, then CH. Whenever it is present in bracket, that means this is present in the branch. So here CH3, then again CH, C2H5. So C2H5. So can I write C2H5 like this? CH2, then CH3, because this is also C2H5. Why I am doing this is it will help you in naming the compound. So this is your final structure of this compound. Now what you have to do is, again you have to start naming. Naming require halogen. This is your halogen. So your numbering will start from this side or this side. This side because it will give you 3rd carbon. Here if you do, it will give you 1, 2, 3, 4th carbon. Also you cannot number it from here in between because it is not the longest. Your numbering should be done so that a longest carbon chain is selected. So we will start from here. 1, 2, 3, 4, 5, 6. So 3 degree you have chlorine, 4 degree you have methyl. C come first. So 3 chloro, 4 methyl. Then you have 3 chloro, 4 methyl, rest nothing, hexane. Hexane. 3 chloro, 4 methyl, hexane. And also it is the carbon which is attached to the chlorine is attached to how many other carbon? 2 degree. So it is 2 degree alkyl halide. Alkyl halide means all the alkyl group is attached to a halogen. So let's go to the thing. So let's jump towards the 3rd question now. 3rd question is CH3. First open the structure. CH3 as it is, CH2, then a carbon, this is bracket, that means it's present as a branch, CH3 here on the top and then here, then CH2, then iodine. Okay, so this is your open structure. Now your job becomes very easy, just you have to see where it is the halogen and number it accordingly. Number your halogen is over here, so numbering start 1, 2, 3, 4. So first position you have iodo, so 1 iodo, then 2 position you have 2, 2 dimethyl butane. So this is the name of this compound. Find out the degree of this carbon. This carbon is attached to how many degree? And this carbon is attached to the carbon which is attached to how many is the carbon? Only 1. You don't have to look for this. So it is again 1 degree alkyl halide. So 3rd question is also done. Okay, so what you will do first? First we will open the structure. You have to be very careful while opening the structure. If you do here wrong, then your answer will come wrong. So CH3 2 times. So CH3 2 times in bracket means it is attached as a branch. So 2 times CH3 over, then C, then CH2, then CH. CH is having a bromine as a branch because it is in bracket, and then C6H5. C6H5 means a benzene ring, phenyl group, what we say. Now what you have to do is, you have to just number it. How you will number? Look for your halogen. Here your halogen is, this is the carbon, so 1, 2, 3, 4. Correct? CH3 2 times, okay, C, CH2, CH2, CH, bromine, C6H5. Now, how you will number? 1, 2, 3, 4. 1 is with bromine, 3 is having methyl group here. So 1 bromo, 3 methyl. This will also act as a branch. This is known as phenyl group here. Phenyl butane. Benzene ring, when it is written in IUPAC, is also known as phenyl because we are using as a substituent over here. So phenyl butane. Now tell me the carbon which is attached to this bromine is how many degree carbon? 1 carbon attached here, 1 carbon attached here to 2 degree. Now will it come in alkyl halide? No. Now look here. Benzene ring, a carbon and a halogen. Benzene ring, a carbon and a halogen. It comes under benzyl. So 2 degree benzyl halide is the correct answer here. 2 degree. 1 minute, let's change it. Okay, benzyl halide. So I hope this all is very clear. We'll finish before we start because now the complexity of the question has been increased. So I'll give you a little trick about all the IUPAC naming. There is a formula which I have prepared. You have to follow this, and after that your all IUPAC name will be very easy. If you can see over here, something I have written in red color. 2 degree prefix plus 1 degree prefix plus word root plus 1 degree suffix plus 2 degree suffix. Normally the most complex IUPAC name also have only these things. It is may possible that this is not there, but normally these all things are written for all the IUPAC system name. If it is 2nd degree prefix is not there, no problem. If 1 degree prefix is not there, but you have to follow the same sequence. Now what is the meaning of secondary prefix, primary suffix, secondary suffix, word root? I hope you know only. Secondary prefix tells you about the branch. 2 methyl, 3 ethyl, 2 propyl, these all things. Primary prefix normally present or may not be present. The reason, if there is a cyclic chain, that time we use cyclo, bicyclo, tricyclo. If there is a cycle present, that time we use this. So normally it will be not visible over here in these examples. Next, word root. Word root is in the longest carbon chain. How many carbons you have, like pentane, pent, hexane, heptane. In the carbon chain, what you are taking as a parent chain, how many carbons are present? This word root gives us this information. Primary suffix gives you if there are any double bond, triple bond present or not. Basically the bonding. For example, you say butane, that means all are single bond. I say butene. What does that ene tell us? Ene tells there is a double bond at second position. So this primary suffix gives you that information. What does the secondary suffix give you information? Secondary suffix tell us that which functional group, main functional groups are present over there. For example, I wrote pen-to-ene all. That means OL is your secondary suffix, and it will give you information regarding alcohol. So I hope this formula will help you. Now we'll use this, and I hope you will be able to understand this. So let's hop on and open the structures first. Okay, what I'll do it first, I'll open the structure CH3. I'll draw it very small so that it is visible to everyone because we have constraint of space. CH3 in bracket, that means there is a branch, then H, then CH, then again bromine, then CH3. So I hope this is very easy to remember. Now find out where is our bromine. Our bromine is present over here. So the numbering will be 1, 2, 3, 4. So 2 bromo, 3 methyl butane. Now if you see here, only 2 degree prefix is there is no 1 degree prefix. This is your word root and ane is your primary suffix. There is no secondary suffix also over here. Now tell me the carbon which is attached with the halogen is how many degree carbon? 2 degree carbon because it is attached to 2 degree. 2 different carbons, so 2 degree alkyl halide it is. I hope you are able to understand it very easily. Sure. Let's go to the next one. CH3C. First open the structure. CH3C C2H5. Can I write it as CH2CH Here I will just write it as CH2CH C2H5 is this only. Then CH2, and then here is the Br. Now this is the open structure of it. Now what you have to do is you have to do numbering. This is your halogen. So start numbering from here 1, 2, 3, 4. So this is the longest chain. Now 2 degree we have 2 types of substituent. So first we have bromo, then 2, 2. Okay, first there are no common substituents. So ethyl and methyl, what comes first, E or M? E comes. So 2 ethyl, then 2 methyl, because here this is your ethyl, this is your methyl, then butane. And the carbon which is attached to the bromine is how many degree carbon? 1 degree. So it is again 1 degree alkyl halide. Okay, let's do this one now. So let's open the structure. CH3. So CH3 C as it is. Bracket means always in branch. Chlorine. C2H5 again in branch. Can I write C2H5 like this? I hope it is correct. CH2CH3 is also C2H5. Why I am writing it? I will tell you in just 1 minute. CH2CH3. Now the reason why did I write CH2CH3 not as C2H5? The reason it will be easy for find the longest chain. Now look here. This is your halogen. You have to focus on halogen here because there is no double bond, triple bond, anything over here. So your numbering will start 1, 2, 3, 4, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So third position we are getting chlorine. So your name will be, this is also a substituent. So 3 chloro, 3 methyl pentane. Simple? Yes, very simple. Next, what is the degree here? The carbon which is attached to chlorine attached to how many other carbons? 3 degree carbons. So the answer is 3 degree alkyl halide. Now let's solve this one. First, always try to open the structure. This structure can also be written as CH3 CH double bond C, bracket means again a branch, chlorine, CH2 CH, again 2 brackets, so a branch CH3 here, a branch CH3 here. Now again here chlorine is also present, double bond is also present, so both are, luckily both are present in the same side of the numbering. So 1, 2, 3, 4, 5, 6. So 3 position you have chloro, 5 position you have methyl. So 3 chloro, 5 methyl, a hex, and 2 position you have double bond ene. So this is the IUPAC name. Now find the degree. Chlorine attached to this carbon attached to how many other carbon? 2 carbon. So as it is 2 degree, if you don't name also it is okay. But if the important thing is halogen which is attached to the carbon is a sp2 carbon, directly attached to a double bond. So it is vinylic halide. You can write like this. Chloride also you can write, but vinylic halide. Okay, so let's open this structure now. CH3 CH double bond CH carbon, a bromine, CH3 branch to this carbon only, CH3 CH3. So how many carbon? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now let's start numbering. Here bromine and double bond is there, so preference will be given to double bond. 1, 2, 3, 4, 5. So third position we have double bond, fourth position we have bromine. So 4 bromo, 4 methyl, pent, 2, 3 ene. Also now the bromine attached to the carbon is 3 degree carbon, so 3 degree. Now if you see the bromine attached to the carbon is the sp3 carbon which is attached to a double bond, so allylic halide. ये 2 इन रहेगा क्योंकि यहाँ 2 पे डबल बॉन्ड. ओके, चलिए अब करते हैं नेक्स्ट वन. लेट्स स्टार्ट विद नेक्स्ट वन. पैरा क्लोरो C6H4 CH2 CH. फर्स्ट ऑफ ऑल ये P and all, I hope you know the para, ortho, meta, these are common name system in benzene. So C6H4, I will draw it here. C6H6 is your benzene. H4 means 2 hydrogen has been substituted. So this is your benzene ring. Para position there is chlorine. Then this is your first position, CH2 CH CH3 CH2. So CH2 CH CH3 CH3 twice, that means it is a branch. Now how to number this all and how to name it? First, always give preference to halogen. So your numbering will start from here. 1, 2, 3, 4. One position, what do you have? Chloro. So chloro part is over. Now at fourth position you have substituent. Now how to name this? Name it separately. 1, 2, 1 dash, 2 dash, 3 dash I will put. Instead of 1, 2, 3 I will put 1 dash, 2 dash, 3 dash. In many books you will just see 1, 2, 3 only, so no problem. The thing is, which 1, 2, 3 I am talking about, it is very clear for you. So 2 dash, what we have, what you have to do is, if there is a main substituent, big substituent outside the benzene, think it as a separate question and then solve it. Don't think and there is benzene ring, just think about this. What is this? 2 dash methyl. Now methyl is over, 3 carbon. 3 carbon is prop, all single bond in, but the thing is here there is one more hydrogen removed, so propyl. 2 methyl propyl. So substituent is over. Now what is remaining is benzene. So this is your 1 chloro 4 2 dash methyl propyl benzene. Now tell me what will be the degree. Now where is the halogen? Here. This carbon is attached to how many other carbon? 2 carbon. It is directly attached, which is sp2 carbon. So it will be 2 degree aryl halide. Aryl halide. One. Again there is C6H4, that means a benzene ring. Now instead of para, now we have at meta. So meta is this position because substituent will become here chlorine and CH2. So CH3CH. So Cl cannot be attached directly and then Cl cannot have bond with CH2. It will be CH3CH. Next CH2. So CH2 carbon. CH3 how many times? 3 times. So CH3, CH3, CH3. So this is the structure. So little difference is there. Fluorine instead of here it is here, and instead of H they have put one more CH3. Same way. What you have to do? Start with number position. 1, 2, 3. Okay. This is over. Next. Again 1. Only chloro is not there. Now 1 carbon is also there. So methyl chloride or chloro methyl. Okay. Spelling you will take care. Next, again name it as a separate. 1, 2, 3. Which position you have this? You have at 3 position. Third position there is a big substituent. So what you will do? Name it as separately. At 2 position how much we have? We will put it as dash dash dash. 2 dash, 2 dash dimethyl. Then again 3 propyl. 3 carbon, right? Prop, aim, 1 carbon, hydrogen less, so propyl, and again benzene. So 1 chloromethyl, 3 2 dash 2 dash dimethyl propyl benzene. So this is the name of this structure. Now what is the degree? The chlorine which is attached to the carbon is attached to a carbon which is having double bond. So it is benzyl. This carbon is sp3. So it is how many degree? This chlorine attached to this carbon attached to only 1 carbon. So 1 degree benzylic halide. Let's do this last one. Again C6H4, draw a benzene ring. You have to be very focused, otherwise little bit if you missed then your answer will be wrong. Ortho position now. Ortho position what you have? Bromine. Then ortho position means here there is substituent CH, CH3, there is CH3, CH2 and then CH3. Okay, so this is your main structure. What you are supposed to do here? Again 1 position, 2 position. Okay, 1 position what you have? Bromo. So first this thing you finished only. Now think this as separately. Okay, now 1, 2, 3. This is your state change. 3 position what do you have? 2, 3 meth dash 1 dash 2 dash 3 dash 3 dash methyl 1 2 3. Acha, instead of this methyl what I can do is 1 2 3. Okay, methyl propyl benzene. Same thing I did. See, one more thing you have to remember here is no, you cannot name it as minimum substituent. So 1 2 3. So 1 dash methyl propyl. Okay, so instead of this 1 2 3, you have to name it as 1 2 3 because substituents to get minimum position. So 1 dash methyl propyl benzene, 2 degree aryl. So I hope you have understood all this 1 to 12. So we'll continue in the next video with the next question. So bye bye.